When you need to deploy and manage containerized applications without the hassle of setting up and maintaining Kubernetes infrastructure, Azure Kubernetes Service is the perfect solution for you. Instead of spending time on complex configurations, you can let Azure handle the control plane, so you only focus on your applications and workloads. With AKS, you don't need to be a Kubernetes expert. Azure takes care of cluster management, security updates, scaling, and monitoring, and allow you to run highly available and scalable applications with ease. Whether you are migrating existing applications, adopting microservices, or deploying machine learning models, AKS provides the flexibility and automation you need to keep things running smoothly. Let's understand why you should use AKS. You should consider using AKS when you are moving your applications to containers. If you want to lift and shift your existing applications into containers, AKS provides a fully managed Kubernetes environment to simplify the process. You should consider using AKS when you are working with microservices. If your applications are designed using microservices, AKS helps you manage service discovery, scaling, and load balancing automatically. You should consider using AKS when you want to integrate secure DevOps workflows. With AKS, you can connect to Azure DevOps, GitHub Actions, or CI/CD pipelines to deploy updates quickly while maintaining security. You should consider using AKS when you need on-demand scaling. If your application has variable workloads, AKS can scale up or down automatically using Azure Container Instances for burst workloads. You should consider using AKS when you are training machine learning models. If you work with large datasets and AI models, AKS supports GPU-enabled clusters for faster training with tools like TensorFlow and Kubeflow. You should consider using AKS when you need real-time data processing. If your app collects and processes data in real time, AKS provides the computing power needed for fast analysis. And lastly, you should consider using AKS when you need to modernize Windows applications. If you are running Windows Server containers, AKS lets you modernize your applications while keeping them in a managed environment. Bottom line, if you need a scalable, flexible, and secure way to run containerized applications, AKS is the right solution for you. With AKS, you get powerful built-in features that make Kubernetes easy to manage and scale. Let's unpack those features. Using AKS, you can enforce compliance policies using Azure Policy, limit access with Kubernetes RBAC, and integrate with Microsoft Entra ID for secure authentication. You can track your cluster health with Azure Monitor's Container Insights and analyze network traffic using Prometheus and Grafana. You can use pre-built cluster configurations, auto-scaling, and tools like Draft for AKS to quickly move applications into production. You can run workloads across multiple node pools, use GPUs for high-performance computing, and support for Linux and Windows containers. You can connect Azure Disk, Azure Files, or Azure NetApp Files for secure and reliable storage. You can choose KubeNet for simple networking or Azure CNI for advanced networking with custom third-party integrations. And you can work with HEM and Visual Studio Code to manage your workloads easily. Bottom line, with AKS, you can deploy and manage Kubernetes applications effortlessly. Ensure high availability, security, and cost efficiency. When managing Azure Kubernetes service clusters, you need to isolate teams and workloads while making the most of your resources. AKS gives you the flexibility to run multiple workloads securely by using logical or physical isolation. You decide whether to run everything in a single shared cluster or separate AKS clusters based on your security, cost, and operational needs. If you are running multiple teams, applications, or environments, AKS will help you control access and resource allocation, so each workload remains secure and independent. By understanding multi-tenancy strategies, network security measures, and best practices, you can design AKS clusters that are cost efficient and secure. Multi-tenancy in AKS means you are running multiple teams or applications on the same Kubernetes infrastructure. But to keep everything secure, you need to isolate workloads properly. AKS allows you to do this in two ways. First one is logical isolation, which is also called shared AKS cluster, in which you run multiple workloads within a single AKS cluster but keep them isolated using Kubernetes namespaces, RBAC, and network policies. And second one is physical isolation, which is nothing but separate AKS clusters, in which you deploy a separate AKS cluster for each team or application and ensure complete separation between workloads. Bottom line, your choice depends on whether you want to optimize cost, which is a logical isolation in this case, or prioritize security, which is going to be physical isolation. Let's discuss logical isolation first. As mentioned, if you want to minimize cost while keeping workloads isolated, you can use logical isolation within a single AKS cluster. You can do this by creating Kubernetes namespaces to separate teams, applications, or environments. You can do this by applying role-based access control, so each team only has access to their resources. You can do this by enforcing network security with Kubernetes network policies to restrict communication between workloads. And you can do this by using Azure policy add-ons to apply security controls across your cluster. With logical isolation, you get better resource efficiency because all workloads share the same infrastructure. You don't waste compute capacity on idle nodes, and you can scale up or down automatically based on workload demand. However, if you don't fully trust every team or application running in the same cluster, you need extra security controls like a RBAC, pod security policies, and container runtime restrictions. Let's unpack physical isolation now. If you need stronger security and can't risk workloads interfering with each other, you should deploy separate AKS cluster for different teams or applications. This gives you full workload isolation, so no team can affect another team's applications. This gives you stronger security controls, which reduce the risk of cross-cluster vulnerabilities. This gives you independent access and permissions, which ensures each AKS cluster is managed separately. However, this approach comes with trade-offs such as higher cost, lower resource efficiency, and more management overhead. Higher cost means you pay for each separate cluster and its nodes. Lower resource efficiency because unused compute power in one cluster can't be shared with another, and more management overhead because you need to maintain multiple clusters, RBAC policies, and monitoring setups. Bottom line, use physical isolation only if you need strict security boundaries or your organization's policies require separate clusters for each workload. To keep your workload secure and prevent interference between applications, you need to apply a combination of scheduling, networking, authentication, and security controls. Managing where workload run is key. By setting resource quotas, you can prevent teams from consuming excess CPU or memory, while taints, toleration, and affinity rules help you control which workloads run on which nodes. Network isolation is equally important to ensure traffic flows only where it should. You can use Kubernetes network policies to restrict communication between pods, and for added security, limit public access with Azure Private Link and private endpoints. If you want to control how traffic reaches your applications, use ingress controllers or Azure Application Gateway for secure routing. To restrict access to resources, you should integrate Microsoft Entra ID to manage authentication and apply role-based access control, so each user or service only has access to what they need. If your services need to communicate with other Azure resources, use pod identities to ensure secure authentication without exposing credentials. Finally, securing your containers is critical to prevent potential attacks. Always scan container images for vulnerabilities before deployment and enforce App Armor or SecCom to block containers from accessing sensitive system resources. Instead of storing secrets within Kubernetes itself, secure them in Azure Key Vault to keep your sensitive data protected. Bottom line, by implementing these best practices, you ensure each workload remains secure and isolated and allow you to run multiple applications confidently within AKS while maintaining strong security boundaries.